Is it 6i plus 16j for the first one?
6i plus 16j. Okay, and B.
It's Pythagoras for magnitude, so... 292 and then square root that. 17.08 for the magnitude. Bearing. Uh, 69.44.
So let's say 69.4 degrees. So that would be the angle.
Yeah, bearing would be 0.69.
So what we just found would be this one, 69.4 degrees. And so I think they want this one.
Yeah, so 20.55.
And so as a bearing?
0.20.5.
Yeah. Okay, hopefully that's all correct. I haven't. Let's see if that's going across. All right, let's take a look. So 16, 17.1, yeah, and then 69.4, and so the bearing is 20.6. Yep. Any questions about that?
No.
Yeah, that's okay. Let's see, this one, is it worth acceleration? I think it'll be fine there. And then this one looks a bit different because they've written it this way. Let's try this one.
All right. So I've got 4.8 and minus 4.5.
5, okay. 4.3 and minus 12. Okay, we'll see. So what was you thinking for this one?
So F equals MA,
Mm.
and then I just did 60 times by the acceleration.
So the force, so 80 plus 10p minus 75 would be equal to 60 times 0.8.
I didn't add them all up actually. So,
Okay.
yeah. That's probably where I went wrong.
And yeah, how about Q then?
Yeah. Minus 90.
Minus what, sorry?
90?
I'm not sure. So did you do 50 plus 20Q plus 100
Plus 100 equals 60 times minus 1.5.
minus 1.5? And what calculator do you have?
Casio FX 9750.
So graphical.
Yeah.
I'm sure there's some way. So I've just got the CG50. I imagine that's similar. Is there some way to solve equations with it?
I'm not sure about equations like that.
It'll be under equation. So from the start equation, solver is F3. So from your first one, from your first thing, is there like a solver somewhere?
Yeah.
Or equation?
Yeah, there's a solver.
So we can try putting this in. I'm going to try putting in Q as well. I'm sure it would be fine with X. So this time it's shift equals down the bottom. Minus 1.5. And press execute. I'm getting Q is minus 12. Yeah.
Yeah.
Did you get it to work for your one?
Yeah.
Okay, so it's just good to have. So you have it. Okay, I think you're good there. Okay. Exam question. Yeah, it's a tricky one. Okay, how do we do this?
Okay. Do we add the forces together
So that would
so
be.
that it equals R?
Yeah, okay. What do we know about R?
That it's parallel to the third vector?
Yeah. Well, it's. Yeah. And so, how would we represent that? That it being parallel to it?
So we put x brackets minus I plus 4j?
Yeah, we usually call it K. Let's call it K.
Yeah.
Yes, okay, so we have to just construct this equation. How do we go about that?
Do we make K the subject?
So, well, we've got a mixture of I's and J's here.
So we divide the third vector.
What if you were to just look at the I's separately?
Okay, so 2pi minus
No.
ki.
So 2I plus pi is equal to minus ki.
Okay.
And you can divide everything by I. So it's just 2 plus p equals k.
Okay.
So same thing in the j direction.
So 3j plus qj equals 4kj.
Yeah.
And then that would be just 3 plus q equals 4k.
Yeah.
And then to treat them as simultaneous equations.
So the problem is we've got 3 unknowns. So yeah, you treat them as simultaneous equations, I suppose. Yeah. How do we go about
it? We could multiply the p equation by 4, so we get both equal 4k.
Yeah. That would be minus 4k.
Minus 4, yeah.
Okay, yeah. What would you get?
So 11 plus PQ equals 0.
Well, 11 plus 4p.
Oh, yeah. Yeah.
Plus q.
4p, so 5p plus q. No, 4p, yeah. 4p plus q equals 0.
And in fact, that's what we were asked to find. So we can just write it the way they wrote it and just say that's it. Yeah, well done. Yeah, so you can always look at them. You can always look at them separately, the I's and the J's, and go about it that way.
Yeah, okay.
Any questions there?
No. Not so far.
Let's see.
Okay. Do we do like reverse trigonometry? So,
Not trig. Well, okay, yeah, trig, I suppose, yeah.
so I got 6.
So how did you get that?
Tan 45 equals b over 6.
Yeah.
And
so
then
what does b?
Move the 6. So
Yes, because tan 45 is 1, isn't it? Yes. Okay. And so, yeah, go on.
Magnitude, so 6 squared, 36. 72. 8.49.
See.
Mm. 1.5.
And then how would we do the last one?
Is that a Suvat equation?
Yeah.
So you'd use. So that's from rest. So S equals ut plus half at squared. Yeah. So that'd be 18.75.
18.75 meters 7. Am I in the right place? Hang on. So B is 6, that's right. Then 8.49, that's right. A was 2.12. So hold on. Look at the magnitude of the acceleration. So F equals ma. So A would be F over m. The forces were we could just do the 8.49 over 4. Yeah. And so what is that in your calculator?
2.12.
Yeah. Why? How did you get the other one?
I did 6i plus 6j divided by 4. Which
that would still work. But you would then have to get the Pythagoras of that answer, like the two separate ones.
Yeah.
Okay, and then you would just plug that A in instead of
instead of 1.5.
Yeah, so I'll just U is 0, was it? So it's a half times answer times what was the time?
5 seconds.
Squared. 26.5. So that's 26.5 meters. And 26.5, yeah. So any questions there?
No.
Okay, yeah, so the magnitude of a vector, you just do the Pythagoras for it.
Yeah.
Is this one? Is this not kind of... okay, let's try this. I suppose it's the exam question and it's the hardest version of what we were doing.
Okay. So we've got pi plus qj plus 2i plus 5j equals k brackets I minus 2j.
Yeah. And they don't have I or j, so you could just skip straight to the 2 plus p.
Yeah.
Okay, yeah.
So 2 plus p equals minus k. And then 5 plus q equals minus 2k. Oh no, so 2 plus p equals k, not minus k.
Yeah, yeah.
And then we do. So then we do simultaneous equations, and we multiply the p part by minus 2.
You could multiply it by plus 2.
Yeah, we could actually. Still gives the same answer. And then we add them, and we get 4 plus 2p plus, well, 9 plus 2p plus q equals 0.
And then just make it look like the way they wanted it.
So we add 2p plus q plus 9 equals 0.
Yeah. Okay. And B.
So q would be minus 11.
Q equals minus 11. Oh, I see, from the previous one.
Yeah.
Okay.
And then do we add the two forces together?
Yeah.
So 3 and minus 6.
Okay.
So we use Pythagoras.
Yeah.
And I've got 26 degrees, which we add to 90 to get.
Nobody asked you if it's for the angle or bearing or anything.
Don't we need the bearing to find? Oh no, we use Pythagoras. Yeah, no.
Yep.
So that would be 6.71.
Okay.
And take that too. So 6.71 divided by 15 root 5. Gives 0.2.
Equals 0.2 kilos. I believe that's correct.
Yeah.
Just for the... So, where were we? So we showed it, and then 0.2 kilos. Yep. Any questions there?
No.
Yeah.
That's good.
So yeah, you didn't need the angle, just Pythagoras.
Yeah.
Fine. So motion in 2 dimensions. What would you give yourself for that now?
Yeah, I'm pretty confident on that. Okay. I think I'd give myself a tick, yeah.
Okay. And now tricky stuff, connected particles. Yeah, we'll just jump in, see how we do. Okay, how about this?
So do we draw a diagram?
Yes, that could help. So let's say that. Hang on. No. 2 particles. Okay. So this is P. Oh, maybe I should have done it the other way around. Okay. So P is pulled. Okay. By a force of 40 along a rough horizontal plane. So it has a frictional force against it of 10. And Q has a frictional force of 6. Hopefully that's correct.
Yeah.
So we want the acceleration of the particles.
So we use A equals F over M. Force, do we just use 40 and then take away 16?
So it's going to be, yeah, so F equals ma. So it's going to be the force is 40 minus 16 will be equal to
24.
How do you get 24?
40 minus 16.
Oh, sorry. Yep.
And then, yeah, that equals 8 kilograms.
Yeah.
Divided by 8, so that's 3 meters per second minus 2.
Yes, that's it. Okay. B.
I'm not sure how we do that.
What if you looked at just the tension in the string? Oh, which tension? The middle string, is it?
I think so.
What if you looked at P by itself?
So a force of 30 newtons.
Yeah.
So
So the force minus 10.
minus 2.
What other force is there?
The 3 meters per second of acceleration.
So there would also be tension in the string.
Right.
So 40 minus 10 minus T.
Okay. Equals. Is it just? Acceleration times the weight. So 5 by 3.
Yeah. And that's what you solve.
So T equals 15.
Okay. And C.
Well, the string doesn't really have an effect on the weight of the particles.
Yeah, I suppose that the string wouldn't add to the mass, I suppose.
Yeah.
And inextensible maybe wouldn't stretch.
Tension is the same.
Yeah. So that's 15. Inextensible acceleration of masses is the same, and then light tension in this is the same throughout the length of the string, and the mass of the string is negligible. Okay, so basically the string has no mass. The tension will be the same everywhere on the string, so like the same in the middle as it is at the very left, at the very right.
Okay.
And the acceleration of the two masses is the same because it's inextensible. Okay. So Newton's third law, equal and opposite reaction. Okay, let's try this one.
Um, hmm. So do we have 1000 G minus T equals 0.5? No, because that wouldn't be forces.
So if it's moving up,
If it's moving up,
what do you know about T and what do you know about weight?
they act oppositely. So
Which one is bigger?
tension.
Yeah.
So T minus.
Yeah.
Okay. So it's T minus 1000 G.
G is measured in kilos, so it would just be 1G.
Okay. And then 0.5 times 1000 or 1.
So mass in kilos would be 1. Yeah.
So 0.5 G, which...
Yeah.
G is 9.8, right? Yeah.
Yeah.
So that's 4.9.
Yeah. Okay, B.
Would it just be 400 times 9.8?
Well, then it would be 0.4 times 9.8.
Yeah.
But I think, would the fact that it's being pulled up increase that? So the tension was 4.9.
Yeah.
So what would happen there? So it's definitely, it's definitely 0.4 G of a... so if we just looked at A by itself, 0.4. So going up, going up 4.9. It's going down 0.4 g. It has an acceleration of 0.5. And its mass is 0.4. So its overall F equals ma. So the force on B, so would it be its overall forces? Would it be 4.9 going up minus 0.4 g going down? Minus some kind of resultant or whatever equals mass 0.4 times the acceleration, which was 0.5. Oh, hopefully I'm not way overthinking this. Hang on. Let's see. So the tension was 10.3. Where did we go? T. Tension for the whole system. T minus G is equal to A. T minus G is equal to A, yeah. T minus... Oh, because you plus G to both sides.
Oh.
Yeah. That's why, sorry. This one. 4G. So they just called it R. So instead of 4.9, they just called it R. So just whatever that resultant force is minus that equals that. Okay. And then that, yes. So 9.8 plus 0.5. 10.3, is it?
Yeah.
Okay, and then this one, so for A, it's going to be whatever its upward thing is, take away 0.4 g is equal to ma. And so, yeah, they just bundled it all together into one thing, so that's probably simpler. Okay, so what is R?
Would just be 10.3 times 0.5 minus 0.4 g.
I think it would just be, you just solve that basically.
Oh, okay. I've got 4.12.
Looks good. And then have it see.
must be 10.3 by 0.5.
So that's overall is 10.3. On B. 10.3 minus something. Is that it? Equals MA. The force exerted on mass B by the scale pan. Oh, by the scale pan. Well, I think it would just be 10.3 maybe. Because if this is going up 10.3, then the pan will be putting 10.3 in it.
Yeah.
Like the floor or something. So they call it 10. Yeah, 10. So T minus S is equal to 0 because the pan has a mass of 0. Okay.
Okay.
Yeah. Yeah. And so our other one was, they said 4.1, 4.12. Yeah. Okay. So any questions there?
No.
Okay. So then we do those exercises. Oh, there's lots of them. But let's see. There's 1, 2, 3, 4. We'll see them next time. 1 sec. So let's see. This will just load in a sec. So let me take a look at them. Yeah, so I think you're okay for the magnitude. You use Pythagoras.
Yeah.
Bearing. So sometimes they want the angle. In this case, it would be 69. Sometimes they want the bearing. In this case, it would be 20, 21.
Yeah.
So just watch out for that. Yes, so you can always treat the I and J separately, or the right and the up separately to make two equations and do simultaneous equations. What else was that one? Acceleration. Yes, the acceleration. So the overall force, you can keep it as a vector, or you can use Pythagoras to actually get the magnitude of it.
Okay. Yeah.
Yeah, so treat the I's and J's separately, and you can just take out I and J if they're all I or all J. Sometimes there is Suvat. That one was okay. Yeah, so you use the Pythagoras, not the vector, if they want the overall thing. So 15 root 5, they've clearly used Pythagoras and not the vector.
Yeah.
Connected particles. So sometimes you have to take the whole system. So if they want like the acceleration of both of them, you take the whole system. If they want the tension between them, you would just look at one of them.
Okay.
And you can find the tension that way. The modeling that it's light, it has no mass, and that it's inextensible, the tension is the same all the way throughout. There was one more thing about light. No, the acceleration, inextensible, the acceleration is the same for both. And then this one, what was strange about this one? Well, so this is just going up and down instead of left and right.
Yeah.
Yeah. How was that for you, Mieszko?
That was good. Yeah, that helped.
So, anything in particular you want to do next time? If you want, we can continue this stuff or something different.
Let's take a look. Maybe transformations for graphs.
Okay, that's a good one. Tricky one. Any questions for me in general?
Are we carrying on with lessons on Monday?
Yes, yeah.
Okay. Yeah.
Any other questions?
No.
All right. Well done, Mieszko. You did great. I look forward to